Hi, everyone. Welcome to the Power Hungry Podcast. I'm Robert Bryce. In this podcast, we talk about energy, power, innovation, and politics. And I'm pleased to welcome Ray Rothrock. He is a venture capitalist based in California who has long experience in venture capital and the nuclear industry. Ray, welcome to the Power Hungry Podcast.
Good morning, Robert. Thank you for having me. Appreciate it.
It's great to see you. As you know, podcast guests on this podcast introduce themselves. So imagine you've arrived somewhere, you don't know anyone, you have 60 seconds or less. Go.
60 seconds. Okay. Well, I am a venture capitalist, professional venture capitalist, and I have been since 1998. That year, I joined the Rockefeller family, a firm called Venrock, which is a high-tech venture firm based in New York City, and was there for 25 years. I had a nice track record, 53 deals, 9 IPOs. 2013, I retired, went out on my own, and have been investing ever since then. I'm in probably about 20 deals now, including many nuclear projects. So before that, I was a nuclear engineer. I was in the industry. I worked for Yankee Atomic Electric, based in Massachusetts, where we managed 3 plants. And my plant was Yankee Rowe, which went critical in 1961, the first truly public nuclear power plant in the United States after Shippingport, which was a public-private deal with the U.S. Navy.
And Shippingport was in Pennsylvania.
Pennsylvania, right.
Yeah, and that was 1958, is that right? No, 1957.
Right. 1957 went critical, and it proved it's basically a submarine plant on land built by the United States Navy and operated, so the commercial industry could become familiar with operating these things. And then Yankee Rowe was built based on that experience and went critical in 1961.
So Shippingport was 60 megawatts, if memory serves. How big was Yankee Rowe? What was the electrical output there?
Well, the thermal was 365 megawatts thermal and about 180 megawatts electric.
Gotcha.
So considerably bigger,
right,
but still very small. It would fit in the room I'm in here. The reactor was smaller than the room I'm in now.
Wow. So, well, there's a lot to talk about, and I want to focus today on fusion, obviously, because of this recent announcement on that the DOE made, and then fission, of course, and kind of more broadly, how, given your long experience, how you see the industry, because you and I are both hopeful and optimistic, but I think we need some realism here. So how significant, let's start with that announcement from the Lawrence Livermore National Lab last week about the fusion. It's been heralded as a breakthrough, but once I learned more about it, I thought, well, is it really? How important is it?
Well, I think it's very important. And it's a breakthrough because of the following. In fact, the secretary called it a Kitty Hawk moment. And in fact, it was in fusion. Up until the Kitty Hawk event of aviation, a lot of people had jumped off buildings. They had all kinds of flying contraptions. They would leave the ground for a few seconds, but they never were self-sustaining. The Kitty Hawk moment was self-sustaining because it was powered flight, and using basically the shape of the wings, this thing got lift and was sustained and controlled. That's magical. Think about that for a minute. Sustained controlled flight. What was it, 19 seconds? But whatever. It was a short, sustained controlled flight. The NIF, the National Ignition Facility, for the first time, slammed together nuclei to create a fusion event that was self-sustaining for just millionths of a second, maybe even billionths of a second, and it produced more energy than it took in order to start the initial fusion. That's called a Q, or gain, and it was about 1.5 according to the measurements. Now, the total energy to make that thing go was huge. Right. But once it started, it actually ran for a little bit on its own. That is unbelievable. That is a first in fusion, because we've had fusion in labs for decades, but never self-sustaining. So this is kind of a Kitty Hawk moment.
Well, I like the way you describe it. So it was 2 megajoules input and 3 megajoules output, if I recall.
Correct. 1.5. Right.
Right.
Output over input. Yeah.
But it was 300 megajoules needed to charge the lasers, right? So you say it's 1.5 out, but when I think about it, well, actually, isn't it 100 to 1 in? I mean, if you got 300 megajoules to charge the lasers and you get 3 megajoules out, am I looking at it wrong? Or how do you think about that in terms of what's the ring fence, right? I mean, this is always the ring. Where do you determine the boundary about what the inputs versus the outputs?
Right. So this is not a power plant. A power plant, when you draw that fence, it will have to be producing more power than it's ever taking in. That's a fact.
Right.
But this is an experiment where measured the energy at the target. N was 2 megajoules, and the output was 1.5. So yeah, there's a whole bunch of supporting things around it. They call that the hotel load in the power business.
Yeah.
There's ginormous. But the fact that it fused and it put out more than it did meant that the fusion reaction was creating more fusion reactions instead of always the lasers creating it.
I see.
So that's a big deal. That's a really scientifically a huge deal. Engineering wise, we're a long way from a power plant.
Well, and the way I've thought about it is that replicating the sun's kind of hard, right? You know,
Yeah.
This is not.
Yeah, I mean, start to do it with gravity, right? We do it with a magnetic field. Up there's no magnetic field. This is just simply hitting it with these laser energies that when the X-rays from the collision of the lasers with the capsule compress the nuclei, which therefore heats it and creates the density necessary for fusion.
Well, then, so let's talk about what the amount of money that's being raised in the fusion business. You're an investor in TAE, which is based in California. There's another company, Commonwealth Fusion Systems. Together, they raised something on the order of $4 billion. Let me ask that question first. Why are these companies been able to raise so much money?
Well, there's a hope. And look, investors love hope. They always invest in hope. I think there's a reality. Yeah. So let me just, PitchBook reports that it's about 4.8 billion total in fusion. And there are about 33, 4 fusion companies that have received some sort of private financing. That is a lot of money, way more than fission, by the way, but it's a lot of money no matter how you slice it. So what's going on? So the notion here, if you can build a fusion power plant, one, you would have essentially infinite energy because the fuel is hydrogen in some form. Second, you would have no radioactive decay heat issues to worry about. So you have the safety issue just goes away. And then you will have radioactive things at the end, but they're not the fission products that result. So you have 3 gigantic problems for fission that you won't have. There are plenty of things on fusion we could talk about. But why? Because people, there is a belief that if someone could build a break-even facility, then the next step, of course, is to build a net power out facility. And I think the numbers vary. Now, people who invest like me, we understand that sometimes it takes 20 years. At Venrock, we did a lot of drug deals. It took 15 or 20 years. And the point is, you get different investors over different periods of time with different risk tolerances. So the hope would be, and this is my hope as a direct investor, is that we will have that break-even moment that will be sufficient to attract public capital. The company goes public, I liquidate, new investors come along that'll take the risk from break-even to the power plant. That's a fact. The original investment in TriAlpha by Venrock was in 2005. So we've been in it for 17 years. And we think the next machine is break-even. So it's a very exciting time, and this will fit not all the drug deals, but a lot of our drug deals last that long. It violates a lot of principles of venture, more than 10 years and all kinds of stuff. But at the end of the day, my job is to invest in hard things that change the world and make money for everybody. And that's why fusion is attractive. Now, when you say drug deals, you're talking about pharmaceuticals, new developments. Yeah. Sorry, I should have used the word pharmaceutical. I think drug deals go down a lot faster than.
Well, that is probably true. And they usually happen in cash, so that's another
sorry about that
distinction. No problem. Yeah, but then we talked about this a few days ago, and you pointed out and reminded me that the first sustained chain reaction for fission happened, of course, with Enrico Fermi at University of Chicago in 1942. And then there are 15 years until you get to shipping port, which you've already mentioned.
Right.
Is it reasonable to think that from now, given that we've had this Kitty Hawk moment in fusion, that we could have commercial fusion within 15 years?
I don't think so, because we haven't had the break-even moment of the whole plant. Mm-hmm. We've had sustained fission in 42, and then of course Rickover built a submarine to go under the pole, the Nautilus. He did that in 1953, 54, and then shipping port 3 years later. But let's face it, Rickover had the Cold War. I should say Captain Rickover had the Cold War, a lot of controversy, but at the end of the day, he won out and we got it done. So I think it's more like 15 years, probably 5 to 10 years to a break-even plant. And then from there, we will have to engineer a make power plant. Now, we understand how to make power from heat, but there's still a lot of engineering challenges to get the energy of the fusion out into some working fluid that can then be turned into steam to spin.
Oh, I see. I hadn't thought about this. So you need the thermal conversion in through a heat exchanger of some kind.
Right.
So you're going to have to make you're going to have to make steam or something, I guess, or thermocoupler or some other kind of device that would be able to, or not a thermoelectric device. Right. That would convert.
So you need something. You need something to convert the heat to working to a working fluid is what we call it, and then that turns a turbine typically. And we know how to do that really well, but we have never done it. So tell me about TAE. What's the difference? We mentioned two companies, TAE and Commonwealth, that have raised the bulk of the money in fusion. What are the differences between the two companies? What is the I'm assuming there's some technology difference that there are. Two are changing. What are those? Yes, there are. So in fusion, there are many different fuel cycles, they call it. So the most common fuel cycle is called DT, stands for deuterium-tritium. That is hydrogen with 2 neutrons and another hydrogen with 3 neutrons. You slam those together, you get helium, a lot of energy out, and then you get high energy neutrons, 14 MeV neutrons, which are very high energy. So that's DT. The world has been pursuing a DT fusion reaction since fusion was considered doable. And why? Because it has the lowest threshold in terms of the scientific criteria of time, energy, and density. Those are the 3 things you need for fusion. Tri-alpha is pursuing what's called an aneutronic fuel cycle. This is where you take proton and you slam it into boron 11, you get boron 12, proton into boron 11 makes carbon 12. Carbon 12 decays instantly, I think it's like 12 nanoseconds or so, it's very short, into 3 alpha particles. So what's interesting about that? Well, alpha particles are heavy, relatively speaking. They have a lot of kinetic energy, and there's also photons released. So you have 2 sources of energy. But most importantly, what made tri-alpha interesting to me was it was aneutronic, no neutrons produced. So neutrons are nasty things. They kill people. They turn steel into putty. They basically mess everything up, and they make things radioactive. Whereas aneutronic reactions don't. And you will have some radiation, don't get me wrong. There is radiation, but it's sort of on the order of a hospital MRI versus highly neutron-activated steel. So the DT guys, and believe me, let's get her done. let's make it happen, and we'll deal with the radioactive issues of the fast neutron. We know how to capture fast neutrons and all that sort of stuff, but it's a lot of engineering. And then the aneutronic. So aneutronic is a lot higher threshold energy, like I believe it's 20 times that of DT. So it's a harder scientific problem, but if you can make that occur, the engineering is a lot simpler. You have less radiation, don't have neutron damage, and all the other attendant good things that come from that. So it's purposeful in that sense. Now, taking the energy up along the way, maybe you can have a DT reaction in a TAE reactor and then keep going up. And that's all to be determined. We think it's certainly doable, and I think they will show that, but it makes things radioactive along the way.
So then when you're talking about the energy, so you're saying you would need a bigger energy charge to start the fusion then with TAE, it's not going to be 300 megajoules. It could be multiples of that. If we use the recent example. So you're going to have a bigger charging installation to make the ignition happen. Is that, am I hearing you right?
Yeah, I'll give you some numbers. The DT reaction takes about 10 MeV of energy to start. I can't convert that in my head to joules real quickly, but 10 MeV to start.
And that's million electron volts.
That's correct. Million electron volts of energy to start. It's very hot, but the PB11 aneutronic reaction takes about 200, if I remember correctly. It's an order of magnitude. I know that.
Yeah.
So there's a lot more energy, right? So you have to have either a system that can concentrate that energy and then collect more energy and all that's involved. It's interesting. One of the calculations I once saw, all the energy in the current TAE machines would not even melt an ice cube. I mean, it's high temperature, but it's very low density. So it wouldn't even melt an ice cube.
Because it's a very high temperature at a very specific point, then the very
exactly.
concentrated pinpoint to,
Right.
I got you.
Right. Now on that, so I could go on and on about DT and CFS and how they're doing their thing. But
so CFS is following more the model that Lawrence Livermore is pursuing then, that same kind of technology. Is that what you're telling?
Different. Okay. Inertial confinement is what Lawrence Livermore did. That is, you fire energy at it and that the energy squeezes the pellet. DT is called magnetic confinement, and that is you spin up the DT plasma, you compress it with magnetic field lines, and then you pass current through it. And the current through it, I squared R, will heat the plasma such that it'll reach ignition. So that's called magnetic confinement. Yeah.
Gotcha. And now so you're talking now about Lawrence Livermore, and is that's different from what Commonwealth is doing?
Yes, they are different architectures for a fusion reaction.
Gotcha.
Yes.
So I want to talk about fission because, as I see it, fission has plenty of challenges before we get to fusion, but I'm just curious about your background. I know you're a Texas guy, and I know, can you just fill us in on a few of those biographical details? You're from Fort Worth, if I remember.
Oh, yeah. Born and raised in Fort Worth. My parents were from the greatest generation. My dad was at D-Day, and my mom was a teacher's aide there in Fort Worth. I have an older brother. I mean, we're right out of Central Casting. The whole 9 yards. My dad was a machinist after the war, and I grew up carrying his tools around the house, fixing things. And then I went.
So engineering is kind of in your blood, then, or wrenching or knowing tools and how things work is how you grew up, then. Yeah,
it is. But I also am a musician. I love music, and I played musical instruments all the way through college, and still now I play in a band out here called Up and to the Right. But so I had a choice out of high school: engineering, music. And my dad and I took a road trip, and the last stop was Texas A&M, and I had won a science fair award my senior year in high school. Anyway, we presented this letter from the president of Texas Electric Service Company at that time to the nuclear engineering department head, and he read it and said, "Young man, we're going to enroll you right now." And he picked up the phone, and I was enrolled in Texas A&M, and we called my mom. It was quite a dramatic evening, you might imagine. So anyway, I started school and became a nuclear engineer. Then I went on to grad school at MIT, where my work was all around accident analysis and energy liberation from cores and stuff. I did an experiment. It worked quite well. I was stunned. I got out in about a year instead of the 3 years it normally takes for an experiment. And then I went to Yankee Atomic, where I was the nuclear safety engineer on Yankee Row. I was also the fuel. I was in the licensing. I went through one fuel recycle, and I actually was at the plant when we pulled the rods to see if the new fuel would go critical. It was a thrilling moment for me. Here I am, a nuclear engineer. I'm 23 or 4 years old, and we're pulling rods at a power plant to make power. I mean, it was over the top. I can only imagine what those guys in the Navy feel when they pull.
Well, you still just your face betrays the excitement here. How many years later? Now that would be 40. Well, I don't know.
46 or 7 years. Yeah, something like that. Or 43 years. Yeah, something like that.
So your dad was a machinist. I'm just curious to follow that up. What did he do? What kind of machining? Automotive engines?
No. He worked for Johns Manville in Fort Worth, and the plant there was an asphalt roofing company. So his job was to keep the machines rolling. So you take saturated paper, saturate it with asphalt, hot asphalt, and then you pour sand and granules on it, cut it, chop it, and fold it. I worked there 2 summers while I was in college. One time on the line, which convinced me I never wanted to do that kind of work. And the other was actually in his shop, helping him with various things.
Gotcha. And your folks, we're roughly the same age, so they're past now. But they saw you succeed.
They lived a very long time. But
they saw you succeed in nuclear engineering. Then that must have been that's great.
Yeah.
Well, so let's talk about fission now. So when, well, here's the question I wrote down. Why pursue fusion when fission is working
Works.
and then has plenty of its own challenges? So I want to, we can get to the challenges because there are many, and I want to talk about the NRC, but I mean, I mean that question sincerely. Why chase fusion when fission is right here on the plate? We've proven it works. We have more than 50, 60, 70 years of technology, of experimenting, of
Yeah.
knowledge about this. Why pursue fusion when this works?
Well, why did we pursue fission when oil worked?
Oh, okay. Well,
Why
that's
did
a
we
good
pursue
answer.
coal when oil worked? Fusion doesn't come with the attendant safety and radioactive waste issues that
Gotcha.
fission has. The other thing that's not broadcast much, but it's a fact, fusion, pound for pound, fusion is 5 times more energetic than fission.
Mm.
And fission, pound for pound, is 2 million times more energetic, 2 million times more energetic than coal. So fusion is 20 million times. So you look, around power, one of the things I was taught when I was, in nuclear engineering school, the first approximation to a power plant or a chemical plant, any complicated industrial plant, is the amount of steel, copper, and cement. You just do a quick estimate of the volume and how much of that it is. That's within probably 80% of the total cost.
Right.
Well, if you can make it smaller, you've now used less. And so a giant chemical plant is way bigger than a nuclear fission plant. And hope is, a 40-acre fission plant can shrink down to about a 4-acre fusion plant. So you're using less material, using less land. Therefore, it should be more economical. So I think that at the end of the day is what makes fusion interesting. It can be cheaper, better, and safer.
Well, it's interesting. I like that discussion of the material intensity because that has become, I mean, it is very quickly emerging as the key challenge amidst many others. So, the intermittency, the land use conflicts, which is where I live and breathe a lot of my time. And, I've created the renewable rejection database to document how unpopular these massive projects are, these solar and wind projects.
I cite you all the time about that, by the way.
Well, thank you. But it's the material. It's not just the land intensity. It's the material intensity, which is so high, especially for offshore wind, is almost off the charts on the IEA's own estimates. And so that's interesting that you talk that I didn't realize that. When you say 5x fusion over fission, you're talking about the energy, the power density of the machinery.
Mm-hmm. Yeah.
I got you.
Yeah. So it's smaller, more dense, and therefore it's likely to use less material.
Smaller, faster, lighter, denser, cheaper, to quote one guy I've heard.
Right.
Well, so let's talk about then fission, and this is the other, right after. So, there are many obstacles, but what are the biggest obstacles facing this new paradigm around fission? To quote Maria Korsnick, who's been on the podcast, she said, I don't like the word renaissance. She said there's a new paradigm, and I think there are many drivers for that new paradigm. What do you see as the biggest obstacles in the new paradigm to a rebirth of fission in America?
Rebirth.
Okay, well, is that even the right word? Is that even the right word?
Well, well, I don't know.
A new era?
New era. Whatever we can call it. Well, let me noodle on that one.
Okay.
Look, I think the big issue is that the current fission plant world that we live in, the 80 or 90 plants, whatever it is, these are very complicated machines. They're bespoke machines.
Right.
And as a result of that complexity and the uniqueness of each and every one of them, despite the fact they're either a PWR or a BWR, has created a labyrinth of regulations, testing and control and compliance and all this other red tape, if you will, that has become a gigantic burden. Now, couple that with the people that have witnessed it. So this is the way it's been for 30 years. And it's got, when I started, look, Yankee Row was built in 14 months, cost $30 million in 1961 dollars.
Repeat that again now.
14 months, $30 million it was built.
For 180 megawatt
Electric. And it was a reactor that was just identical to the Navy plants of that day. Wow. So it didn't have the regulatory burdens and all the stuff. It wasn't bespoke. It was literally shipping port grown up a little bit. and off we go. So this complexity. So what's just happened is the people now in decision, the members of boards, the CFOs, the CEOs, when you say nuclear power, they think, oh my God, $10 billion, Vogtle, whatever it is, $20 billion. And people have a very hard time breaking out of that mindset. In fact, it makes it real easy when you're in a meeting to just swat fission aside. And no one has proven that it can be done any differently. That's the mode we're in right now. This advanced reactor world that we're living in right now, the last 10 years, if you will, is all about showing the decision makers that there's a cheaper, better way to do fission. And here we are. The ARDP was passed a couple of years ago. The Congress is going to pay for 2 of these machines. We're going to instrument the heck out of them, understand what their economics are, on and on and on. And remember that my paradigm about copper, cement, and steel, well, these machines are smaller. They operate at atmospheric pressure, some of them. So you don't have all the pressure systems. You don't have to have the safety systems. They naturally recirc. They have, Mother Nature provides gravity to do the shutdown sequence instead of all this high-powered shut them down system. So there's a whole lot of stuff that these entrepreneurs are putting forward. And by the way, most of that was experimented up at Idaho in the 50s, 60s, and even the early 70s. Idaho built, I think it's like 52 reactors. And
you're talking about, just to be clear, you're talking about Idaho National Labs, which is
Idaho National Laboratory,
part of the Department of Energy. And then you said ARDP with the Advanced Reactor Development Program. I think you use that acronym.
I'm sorry.
Just to bring people along here. But so go ahead. So, and that seems to me the key issue now. We have a metric ton of paper reactors, and we have to turn the paper reactors into operating reactors.
Right. So to show, and look, I don't know if they're going to be cheaper or not. I believe they are. I think their starting cost is less. Physical deal than what's called the overnight cost. To build one of these things will be a lot less because it's just less complexity.
Right.
And we got to try it. Now, I don't think anyone's going to buy an expensive nuclear plant. I don't care about I don't care what technology you deploy. No one will buy an expensive plant. But we don't know today if we can make them cheaper. And I believe we can, and a lot of other people believe we can. Maria, I think, believes we can. Those are called the advanced reactors.
Right. So a different style, different type of these big 1 gigawatt size reactors. Now we want to make them smaller. We can produce them at scale, right? And more factory type of environment. But that comes with risks in terms of in terms of the scale up, right? But let's talk about the NRC, because Ted Nordhaus had a good piece that he wrote and published in Breakthrough on the Breakthrough website, website. He wrote about the NRC, which was directed by Congress, if memory serves, a year or two ago to promulgate some new regulations. And I want to read this because I'm quoting here that the licensing proposal that the NRC put up is the worst of both worlds, marrying the old prescriptive and inflexible licensing rules to impossible risk thresholds so low they cannot be observed epidemiologically. Needless to say, this is not a recipe for the development of innovative and globally competitive advanced nuclear sector that can meaningfully contribute to America's efforts to cut carbon emissions and clean up its electrical grid. I mean, I've heard this from other people saying that the NRC, this new rule that they've put out, I guess it was in September, 1,200 and some odd pages, that is so complex that it effectively could blockade the development or the movement of these paper reactors into real reactors. Is that how you read it?
I read it somewhat like that. I think, Ted's a good writer and he made great points in a simple way. I think it warrants, if we have a minute, it warrants actually talking about all this. So
sure.
The reactors we have today were licensed under what's called Part 50 or Part 52. I'm not going to get into the details of it.
And this is federal regulation, CFR. I forgot
right.
Okay. Yeah. Exactly. But it's complex, but it's in the federal statutes about how they're licensed.
That's right.
Okay.
And a couple of years ago, a bunch of us worked with Congress to get some new legislation passed to literally force the NRC to think about things differently, because we could see this AR stuff coming down the stream. And so Congress passed, and President Trump signed it into law, and it's called Part 53. I don't know who came up with 53, but that's what it is. And the notion, so just as reactor technology, so just as we've learned so much more about our world and about the physics of the world and everything else, or reactor technology has learned so much, The hope was that 53 would reflect our learnings of the last 30 years. Most specifically, at least from my standpoint, probabilistic risk assessment, which was something that Norm Rasmussen came up with the WASH 1400 report in, I don't know, 1975 or something like that. Huge, transformative piece of work that he did that suggested that you can analyze things without the deterministic. So 53 was the hope that it would come at risk assessment with this probabilistic approach. And by the way, this is how the FAA and this is how the FDA, they do all this probabilistic risk assessment. It's about probabilities. What has happened instead, the NRC has taken 50 and 52 pieces, literally picked up text and dropped it into 53. Now, what text did they pick up? The one that I like to cite, and I'm sure someone out there in the world can prove me wrong 40 ways from Sunday, but the concept is, if you build a gigawatt power plant like Vogtle, you have to put a cement concrete dome around it. You know, I don't remember the dimensions, but it's a giant thing. Why? You have to do it because it's a pressurized water reactor, and pressurized water reactors have a lot of energy, stored energy, and if you have a big leak, the building needs to contain the energy. That's why you have it. Let's go to 2020, where you have one of these reactors that doesn't have pressurized water, operates at atmospheric pressure. Does it need a gigantic cement dome to keep the energy in? No. That problem, that safety issue doesn't come to pass. Physics does not show that you need that. Yet, 53 has a prescriptive containment element. Why? Why do you need a 30-foot thick reinforced concrete dome over something that doesn't have the energy issues that a pressurized water reactor has? It makes no sense. It doesn't, it violates common engineering good sense. Yet that is how this thing has come to pass. Elements like the prescriptive things from the old bespoke days are winding up in this new advanced reactor days. Well, that's expensive. If we force every part, I think I've seen numbers, but it's anywhere from 25 to 35% of the plant is the containment system. What if you didn't have to? Yankee Road did not have a containment. It had a steel dome over it. Half-inch thick steel dome over it.
And that containment system is well, I didn't know it was 25 to 30%, but I just saw there was another announcement just in the last few days that in France, the Flamanville reactor is going to be delayed again. Yeah. And you know that it's been a disaster, but part of it is that the system, it appears, and Vogtle the same, the system has become so big and so complex. You find one little problem, well, it halts the whole thing. The costs go up, the delays again, because it seems that the system has just been made too complicated. So even the effort to make advanced reactors and decomplicate them, simplify it, if I boil this down, you're saying the NRC isn't accepting this new design as a safer, simpler design. Is that a fair way to think about it?
That's a way to think about it. I don't know if the word accept is the word I would use, because I don't know. I've not talked to the staff. But they clearly are taking old ideas and applying them to this new generation of reactors. And that, to me, doesn't make sense. I don't think that's the spirit of what Congress wanted, because I helped write the darn law. Aaron Weston on the science committee, he's up at Idaho now. He did write the law. I actually sat with him and we wrote pieces of it. So except I don't know if it's accepted or I don't know what it is. Maybe it's whatever. The second part of Ted's thing was about it's demanding risk so low that's immeasurable.
As low as reasonably achievable, the ALARA rule, and that's the other big stumbling block. So I just want to make sure that just insert that. Go ahead.
No, you're right. That's where I was headed, but that's exactly the ALARA rule. So how much is too much? Well, there's a lot of risk assessment out there that would suggest that we've already got too much and that you don't need to put more on. And that if something were to happen, you don't have to suddenly go and retrofit 90 plants, which is what happened after 3 Mile Island. So there are methods, there are physics, there is science today that we did not have in the 70s to assess this risk and to understand if you need more. And that doesn't seem to be part of the conversation. And that's very disappointing to me. And look, I haven't done any nuclear engineering in a long time, but I have kept up with science, physics, and probabilistics. And anyway, So
And when you're
that's a
saying,
disappointment.
and when you're saying this, that the Alara rule is the radiation risk is low as reasonably as low as reasonably achievable, that the radiation from the plant would be kept that low. Is that
Yeah.
right?
Yeah, it has nothing to do with measuring it. It has everything to do with it's got to be kept as reasonably low as possible. Well, what's the most significant thing you could do is not build the plant, right? So between what you can measure and have an impact to the public and not building the plant, that is a gray zone that a lot of people, and there's been a lot of math to show that we're well into that zone of making it too low radiation demands.
Well, I've heard this from a friend of mine who used to work in the federal government. He said, and he's a former nuclear Navy guy, and he said, well, the problem with all these regulations is they're making reactors too safe. And I would say, well, wait a minute, run me through that. But that comes to mind as you're saying that, because if you can make all these regulations that pile on regulation. Well, we made it perfectly safe. Well, you've made it perfectly safe at a cost that is so prohibitive you can't build it. Is that, I mean, right. Does that rhyme with how you're thinking?
Exactly right. And they just keep grinding down. Now, you keep grinding down. Richland, Washington, the whole cleanup thing is subject to all this too. And I've seen the math from the Department of Energy that suggests if you were to take the Richland, Washington cleanup and drive it down to the current risk profile of a nuclear fission plant, it would cost about $500 billion to clean it up, meaning that you would have to basically put dirt back where you took out a reactor that's cleaner than the original dirt and less radioactive than the original dirt. And that doesn't make any sense to anybody, but that is what's on the books. And it's a ginormous economic problem.
Well, there is a school of thought, and I've talked with people in Washington about this as well, that that they view the NRC now as so hidebound, so intractable, that there's going to have to be some other regulatory scheme, because because the NRC is an independent agency in the federal government, that the bureaucracies existed to preserve the bureaucracy. And that's a cynical view on it, but that there's a lot of belief that I've heard that the NRC just simply can't be reformed, and that these promising new paper reactors, for broad term, that needs to be moved to some other agency that can handle it, so that we can get going. Because if we don't, the other countries around the world are going to steal a march on the U.S. Is the problem that big with the NRC? Do you believe that we need Congress to create something new, or can the NRC be reformed?
Wow. Let's see. What do I want to say? You can pull up my Blue Ribbon testimony commission to the Blue Ribbon Commission that I gave. And in my 11 minutes, I managed to propose a new commission. One focused on current operating fleet and one focused on new things. I've thought this for a very long time, not because I think the old NRC is, the results are great. Look at the results. We're very safe, unbelievably safe, but we're also very expensive. And that's not necessarily good when you think about the new things. So I've always advocated that. Now, how hard is that? That's impossibly hard to pull off. I can't imagine. And
because you need an act of Congress.
You do. And I should be very careful. I have no firsthand knowledge. I've never met the current commissioners. I have a lot of my classmates went to the NRC. They're now all retired. So I've got no really current people there. So I depend on the NGOs who go in and visit and talk and report out, like Ted with his thing. But I am, over my, 34 years as a venture capital, I've built a lot of organizations, and I understand how culture develops and how culture can kill and culture can win. And so when I look at this process of this new thing called 53, and they're just sort of taking the old and throwing it in, that just reeks of a culture that is not creative, not being challenged. They don't understand what 53 is all about in the mission, and maybe they need to be educated and stuff. One of the things I have investigated is the sort of org chart of the NRC. Actually, it's on the web, so it's not like I did something special. I just simply thought about it. The NRC doesn't have a CEO. Companies have CEOs. The FDA has a CEO. The SEC has a CEO, a lead commissioner who is not just the chairman, but I mean the lead. And I worry that one of the ways that in the private sector that we fix companies that are broken or going the wrong way is we bring in a new leader with the right culture, the right attitude, and suddenly things change. I don't know where I would put that person at the NRC today, because the org chart is just kind of amorphous. There's the commission, there's the staff.
That's really interesting, Ray. So there's no because there's no definitive leader saying that effectively would crack the whip on the people who work there. Then you're not going to change direction unless you have someone forceful who really, where the buck stops there, right? I mean, to use the buck's, Harry Truman.
That's exactly right. Now, I'm taking a lot of liberty in that analysis, but man, I've been involved with 70 companies, and I'm on the boards of companies with 10,000 people and stuff. So the NRC, I think, is 2,000 people. I've got a lot of companies that have that. So I understand how, and boy, culture goes all the way to the bottom. Rickover. We need an Admiral Rickover to come in at this point, but then it just isn't going to happen given the structural constraints of the NRC and the congressional sort of how they feel and what have you. So that's why, look, if the existing structure doesn't support that kind of leadership change, and again, I don't want to. I'm sure this sounds critical of the commission, but none of them have that kind of authority that I can read in the statute, or no good lawyer, and I know several in Washington that live in this world. It just doesn't exist.
So if the culture is wrong and there's no accountability, there's no fixing.
Not easily, that's for sure.
But to change that org chart would require an act of Congress.
It would, yes.
So
just
even to change
the org chart of the DOE, it takes act of Congress. Yes.
So even to change that org chart would take an act of Congress, or to create a new entity would also create or require an act of Congress.
Right. So, but I think it's an easier act to change the org than it is to create a new entity. I mean, right.
Right, because then you could, and if that were the case, then you get a CEO in there who really has marching orders from Congress to say, "Damn it, make this happen."
Instead of just a statute that goes down on the 5 commissioners, and then they got to figure it out. So yeah.
Right. So then the commissioners become the board of directors, and then the CEO is in charge of then making getting the staff, I'll just say, whip them into shape, or motivate them to say, no, we need to do this right and make sure we can get these new designs into the marketplace.
Right, and for all the reasons we know, and I know a lot of the former chairmen. I've worked with them and testified in Congress with them. In fact, in times past, a lot of them would take issue with everything I just said because they thought everything worked tickety-boo, but we're not there anymore. We're in a new world where these new reactors need to be evaluated differently. Again, same safety, we want to make them safe and all that, but they just have to be evaluated differently because it's not a PWR. It's not BWR. It's a different beast.
You mentioned, just to clarify, you testified before the Blue Ribbon Commission. How long ago was this, and what was the commission? I'm sorry?
This was under President Obama. He asked Secretary Chu it's called America's Blue Ribbon Commission on Future of Nuclear Energy.
Oh, right. And that was the same one that investigated the new waste disposal. That was part of the same commission.
Same commission.
Okay.
Yeah, it investigated all the elements of the whole nuclear supply chain and fuel cycle.
Gotcha. Okay.
The senator from New Mexico,
Domenici, Pete Domenici. Yeah, he's now
Pete
retired.
Domenici was the chair.
Right.
Susan Eisenhower, Dick Meserve, but it was blue ribbon. Anyway,
Gotcha.
They called me up as a VC and said, "Hey, can you come and explain how innovation happens and how we can help?" So that's what I did.
Gotcha. So let's talk about Congress for a minute, because I have written about this in the past, that the Democratic Party for many decades, in fact, was kind of reflexively anti-nuclear. Now, it seems to me that there's been a change. And in the 2020 election, for the first time since, I think, 1974, if memory serves, 72, that the Democratic Party actually said something nice about nuclear energy. Is there, that's a preface, is there now a bipartisan support has it changed on Capitol Hill? Are Democrats on board with nuclear energy today, in your view? And I'm not asking this as a partisan. I mean, how do you see it?
Well, I am a nonpartisan person. I'm not a member of either party, so I'll just put that out there. I don't think the party overall is in favor. I think too much leadership in the Democratic Party still has a zero-sum game that wind and solar is going to win there, take care of everything, and this other stuff doesn't matter. and that I'm going to pick one or the other. And all the climate scientists, all the research, and it's just gotten worse. We need everything. We need all the above. Furthermore, we're going to actually need to take carbon out of the atmosphere, which is a whole nother technology that takes a lot of energy to do. But anyway, I think they're very slow to grasp this. You need it all. There are some surely have, but I don't hear the White House talking about this very much. I hear John Kerry talking about it. Maybe he's in the White House. But I don't.
And Cory Booker is notable as a Democrat.
Yeah. There's several that are sure.
And New Jersey has been out front in preserving their nuclear reactors, and which was happened before California, before Illinois. Kind of is forgotten now because I think it was 2018 or something.
So there is Democratic leadership, but I don't think if you called up a bunch of the senior leadership, I don't think you would. Nuclear is not going to come out of their mouth first.
So what would it take to? Well, see, and this is the disconnect, it seems to me, because that party has been so much focused on climate change, right, as their issue, right? And yet for them to not embrace nuclear energy when so many climate scientists have said, you can't get there from here, mister, if you don't have nuclear. And to me, that's just a lay down hand. Well, hello, duh. There's no way you can scale renewables to meet the challenge for a whole lot of reasons that we've talked about. But I don't know. Maybe that's
I think you're. Look, I think they're playing old tapes. This is what. Remember, we started this whole conversation. I think there's these old tapes about these bespoke gigawatt 10 billion. I mean, I just think that they haven't taken the time to intellectualize, to really run it to ground in their own mind that this is not your father's or your mother's nuclear. This is new stuff. This is different stuff. And there's some, what do you call it? I don't know. There's some face-saving comments and things like that. But at the end of the day, and look, the IRA has a lot of, keeping the existing fleet going. No one disagrees with that. But the new fleet and doing that, Congress, actually, I don't know if I would love to go interview. I think they believe they've already solved the problem by funding the ARDP, the Advanced Reactor Development Program. And by golly, that was huge. That was before IRA. I mean, that was thrilling. I couldn't believe the kind of money that came out of Congress. And
the Inflation Reduction Act, you mentioned IRA, that's something like $3.5 billion or $4 billion for support for new reactors, which is significant. It's a drop in the bucket compared to what they appropriated for wind and solar, but I digress.
Yes, but it's huge. It essentially gets a couple of reactors built. So we'll know whether they're going to be cheaper and all the issues. To help, the NRC will have to write new regs. They will have to write new things about these reactors. Well, we need to build some to see how it goes.
Well, so let's move away from the regulatory regime to this recent announcement by TerraPower. And I was in Washington in October for the IAEA's ministerial, and TerraPower was there announcing their plans for their Natrium reactor in Wyoming and expanding work. They announced the thing with Pacific Corp to explore 5 other additional reactor sites. But then just a few days ago, they said, oh, well, we're going to be delayed at least 2 years because we don't have the fuel. So let's talk about HALEU, high assay, low enriched uranium. That's the fuel they need for their reactor, as do a number of the other. I'm going to use this term again because I don't know how else to, the nuclear startups or the paper reactor companies.
Yeah.
How big of a problem is this fuel availability, which that HALEU, the only supplier is from Russia right now. So how big a problem is amidst, we have the regulatory issue. We won't talk about waste for a while, but just the fuel issue. How big of an obstacle is that now?
Well, that all depends on how fast you think these things are to come online. If you think we're going to build 50 reactors in the next 10 years, then we got a big issue. If you think we're going to build 3 or 4 reactors in the next 10 years, then you don't have an issue. The Navy has lots of fuel that can be downgraded. The enrichment can go from whatever the Navy requirements are, which are extremely high, to 20%. Or we do have technology in this country to enrich, but it's not in sufficient volume to supply a full-on industry. So we're somewhere in that zone. Centrus has this capability to enrich, but it's all small. It's all small potatoes because a lot of research reactors have high enrichment for obvious reasons. So I don't think it's a big. Again, it depends on what you think the forecast is. If you think you need 10 reactors worth, I suspect we don't have 10 reactors capability, and we are dependent on Russia The term of art here is a SWU, SWU, which is the working unit to enrich. And the U.S. gave that up a long time ago because it was too expensive. Other people did it more cheaply. You do it with centrifuges, which is what Iran is doing, and others. So
is that SWU, SWU?
SWU is.
And what does that stand for?
Oh gosh,
something uranium.
Something working unit. Yeah, what is it?
Okay.
No. System working unit. It's not very descriptive of uranium enrichment, but that's the measure of what. In our capacity, it's extremely low. It's basically to research reactors, and the world gets most of its enriched uranium from Russia.
Right. So it was 14%. Reuters put the figure at 14% of, I'm quoting here, that 14% of power stations in the U.S. rely on Russia, along with, this is the part that, along with 28% of their enrichment services.
Yeah.
So, but then the uranium is only part of it. It's the uranium. It's not just mining the uranium. You have to turn it into something you can put in a reactor and make it work.
Right. You got to manufacture it into the right form.
So and I know Centrus has a deal with the DOE on this, and that they're starting to ramp up their facilities. But is it Urenco? And there's one other company I think that's in the running here in terms of this HALEU. But so who else? What are the other startups that are going to require HALEU? Is it
pretty much every one of them except NuScale. NuScale is an SMR, a pressurized water small reactor.
Mm-hmm.
But X, they'll need it. The two ADRP winners will need it for sure. Anybody with a molten salt kind of reactor, Radiant Nuclear down in Los Angeles will need it. And you might ask why. Well, the more enrichment you have, the smaller the physical size can be. So if these things are small, but they're putting out a lot of power, 300 or 400 megawatts, then you need slightly enriched uranium. That's point one. Point two, for the molten salt and all that, you need that much enriched uranium just to get the thing critical because of the poisons, if you will, neutron poisons that exist in the reactor. Because you have to moderate it and all. There's all kinds of technical reasons for it. But it's about making them small.
So we have the regulatory challenge, the fuel fabrication challenge that are kind of go hand in are going along in parallel, that both need to be solved, and they need to be solved, as my father used, pretty damn quick. But is it possible in this Congress with a Republican House, Democratic Senate, Democratic White House? I mean, do we need the president to just stand up and say, damn it, we need to make this happen? I mean, it seems to me that would be, and as a Democrat, that would be the Nixon goes to China moment. But should I be holding my breath on this?
I don't hold your breath, please. I don't know if it's this Congress. Again, it's about timing. I think, seriously, Robert, if we build 3 or 4 of these things, show that they were economic, and suddenly people put out a couple of purchase orders, the HALEU supply chain would pop up pretty darn fast. We have the uranium in the United States. We know how to make these centrifuges. We could build this stuff pretty darn fast and supply our own reactors, and maybe even the ones we would export of these technologies. So I'm not too cynical about HALEU, just because first of all, we're not going to build 50 of these things in the next 15 years.
So you put that as a second order challenge behind the regulatory issue.
That's right. Yeah. Because you're not going to put any steel in the ground without the NRC saying it's okay. No steel, no cement. Right.
Gotcha. So then which countries? I've been following Rolls-Royce. They've made several announcements on that they're developing a reactor, very small footprint, by my calculation, 10,000 watts per square meter, which is just an extraordinary, very small footprint. Is it, and I've talked to people in the industry that, in fact, Brett Kugelmass, his opinion is that nuclear energy, the new fleet of reactors, the new paper reactors, they will have to succeed overseas before they succeed here. Does that ring true to you? Do you think Europe is going to steal a march, or Asia is going to steal a march on the U.S. in this area?
I think it's quite possible. And why? Because they have a national security energy issue that is very different than the United States. Nuclear power, not nuclear, electricity demand in the United States hasn't changed more than a couple of percent in decades.
Right.
It's not going to change more than a couple percent in decades unless the IRA gets completely deployed, in which case demand will go up. But until it goes up, no one's going to buy any more big plants. It's just a fact.
Right.
Europe is in a very different situation with the gas dependency on Russia and the Ukraine. And I mean, the sort of if you think about priorities, national energy security is now probably number one in the UK and all the Nordics and even Germany, France. So I think they will go a lot. They're not going to stand around and wait for the NRC to come up with Part 53. They're going to do something on their own. Canada is already ready to go. So I just think they have a different priority set than we have.
And so, does it boil down to the fact that, well, we have our own hydrocarbons, we can depend on our own natural gas, so there's not as much urgency here, to paraphrase or put it a different way than what you're saying.
Yeah, absolutely. Well, we just don't have the other than UAMPS, who has written a PO for a nuclear plant lately?
And UAMPS is Utah Associated Municipal Utility something, but NuScale is going to build their first reactor at UAMPS. It's going to be at on the site of Idaho National Labs, but UAMPS is going to be the off-taker of that when that plant gets built. So in terms of the handicapping the U.S., so is NuScale the one that's definitely in the lead now? They seem to, in terms of permitting from the NRC, they're using the same light water technology that's existed for years. And so are they the one now, the leader and they've gone public? Are they the one to bet on in terms of getting that first reactor built?
They are the only ones you can bet on right now to get the first reactor built with that clarification. Right. All of the other advanced reactors, the paper reactor guys, as you call them, that's not a bad term. There's a funny Rickover quote about that I'll save. Are all using Part 50 and Part 52 because Part 53 is unknown to them. They're early. They got to get going. Part of the ARDP requirements was you need to have pre-conversations with the NRC so that Congress can be assured you can actually build something. So all that's going on in parallel. So these early reactors, from the early paper reactors turned into real reactors, are all going to be Part 50, 52. We'll see how many get built under 53, if any get built under 53 ultimately, but that's still, that's work in process. So I think the first 3 or 4 that we're going to build are going to be Part 52, 53. And that's a 4 or 5 year process. 4 or 5 years.
Right.
NuScale, as you pointed out, was pressurized water.
Right. And they spent $1 billion roughly to get their permit through, as I recall, through the NRC, which is just a staggering sum of money for
existing technology. It doesn't add up. I mean, at Venrock, we looked at NuScale. I visited Jose Reyes. I mean, he's a great guy. It's cool technology, a natural circle, all the things that you would want for safety. And I remember I called the NRC and talked to, I forget who it was. This is like 2009 or 2008. And I talked to them, I was interested in time, I was interested in certainty and so forth, and they couldn't answer anything. So
here we are, 14 years later. I interviewed one of the former CEOs at NuScale, 10 or 12 years ago myself. I mean, and published that interview. It was a long time ago now, but
a long time ago. Yeah.
But they're still not, they're closer, but they're still not close to putting steel in the ground.
I remember back then, Jose had worked at the NRC. He was an NRC guy. So he knew the issues, the licensing issue, he knew the technology licensing issues, and he tried to alleviate all that in the NuScale design so that it would go quick.
Well, so we've talked about Europe. So what about the other countries? I mean, let me ask it this way. How essential is it fundamentally essential that the government have a big role in the deployment of new nuclear? Because we see this in Russia, we see it in China, we see it in South Korea, that they have national champions. They have nuclear companies that are their national champions. Is that going to be essential for it to happen in the U.S.? It seems like we're trying to come at this from this still free market design. Yeah. Is that just fundamentally flawed, or are we going to have some government some national champion company that's going to be the ones that we appoint, say, no, you're our nuclear guys?
Now you're asking a venture capitalist who's a big free market guy to opine here. Look, the U.S. government runs about 160 reactors. It's called the United States Navy. I think it's 160, something like that. Quite nicely. No incidents ever in the entire history of the U.S. Navy. That's one. Second, how much was the IRA? Do some quick math. How many nuclear plants could you build with the money allocated to nuclear in the IRA? You could build a bunch. And they could be just Navy plants on land. Hey, we did that, called Shippingport in 1957. The U.S. government could step in here. Look, the taxpayers just wrote a giant check for the IRA. Why couldn't we write But question is, where's the demand?
Right.
I don't see it. So the government has to have a policy to substitute those CO2 emitting sources with non-CO2, and that would be a gigantic, hard thing for either party to pull
Sure.
off.
Well, it's interesting you talk about the Navy because now we have the Rosatom has deployed the nuclear plant in Pevek in Siberia using submarine reactor technology, but it's a power ship, which to me is a very interesting idea. Thorcon is coming forward with the power ship idea, which to me seems really intriguing because so much of the world's population lives on the coast. I've seen the power ships myself in Lebanon running on fuel oil. If you could just pull a ship up and you could make it work, that seems like a whole different possibility as well. But as you point out, even if the U.S. were to do that, still got a lot of hurdles in terms of demand, et cetera, and licensing, commercialization, et cetera. So anyway, just a passing thought.
Yeah, I mean, I can't imagine rolling one of these up the Hudson River and parking there at Pier 58 or whatever.
Right. Or where Indian Point go connect.
Oh, hey, we have a nuclear reactor near New York. Oh, yeah, I forgot about that.
Yeah, which we stupidly shut down, but that's a whole nother set of issues.
Yeah.
So let me revert back to where you live, and you've invested. Can you talk any more about the companies, the nuclear focused companies that you've invested in? Do you care to list them? I mean, we mentioned TAE. Yeah. Can you talk about those companies and why you invested in them and why they intrigue you?
Yeah, it's a very good qualifier, the intrigue. That's good. So Radiant Nuclear in Los Angeles intrigued me because this is a SpaceX team, which is in the agile hardware development. So part of building anything physical is you got to do it fast and frequent, lots of cycles. So it's an extraordinary team. They also were backed by Union Square Ventures out of New York, so that was encouraging to me. So let's just be, I'm not writing $1 million checks. I'm writing something less than, but a bunch. So I help them out, of course. Doug calls me up and we chat. I've made introductions for him here, there, and yonder. There's a company in Seattle called Avalanche. I can't say too much about it. It is a fusion company. They took an existing machine made by another company for a whole different purpose and repurposed it towards aneutron fusion. And so far, so good. The results look pretty interesting. They've only raised low two-digit millions. They didn't build anything from scratch. So what was unique, they started with existing technology from other industries, and the team came out of Blue Origin. So, I mean, this is talent built on the shoulders of other people's stuff. That is an encouraging thing. Some of the other nuclear deals, I'm in a nuclear battery company. So imagine a 10-watt nuclear power supply for either deep ocean or on orbit. There's thousands of applications need 10, or if you put them in a bank, maybe 100 watt. This has been a hard problem. We've got RPGs and all that sort of stuff for deep space, but those are plutonium based. This is non-plutonium based. Very important. I'm into some scintillation detector company called Radiant Nano. Radiant Nano. It's for detection. So this could be used to sniff luggage. This could be used to interpret inspection of nuclear class things. Again, this would be a tool used by the industry to make things go faster. That's one. I've not invested in any of these companies that make like molybdenum and other isotopes for medical purposes, but I've surely looked at them. That probably was a mistake on my part because they'll have revenue quickly. Let's see. That's
then I believe you're in Oklo as well, right? Which is
thank you. Yeah, I'm in Oklo.
Backed by an Austin, also backed by an Austin venture firm called Trusted Ventures. They're an investor in Oklo. So
and DCVC and others. Yeah, no, I'm in that deal as well. I've known Jake and Caroline when they were in grad school, and been watching that develop. And
and Carolyn, by the way, has been on the podcast. She's from Tulsa, like me. So So I had she's
that's right. She is from Oklahoma. I remember that now. Yeah.
Right. So
So it's a smattering of those kinds of companies. I'm also in deep isolation. Liz Mueller up here in Oakland. Right. I learned after I left Venrock, I did some lecturing at MIT in their nuclear department on venture capital investments and stuff. This is when entrepreneurship was starting to catch hold there. And Richard Lester, who was the department at the time, gave me a quick course on technologies to deal with radioactive waste. So, and one of them is deep hole isolation. And this company formed up based somewhat on that, but other things. And so I got pretty serious money in that project because I think that is a very viable way to deal with radioactive waste.
And Elizabeth Muller from Deep Isolation has also been on the podcast. So,
good, yeah. So that, I mean, that's a pretty serious endeavor. I mean, they take their jobs very seriously there. But anyway, they've raised money successfully, and they've demonstrated. They down at WIP, they put it in the ground and brought it, and they've done amazing things. So, if you think about, Robert, the areas that we have to have safety, we have to have fuel disposal, we have to actually have cheap reactors. I've invested in things that I think sort of touch bits and pieces of that.
Sure. So I know as a venture capitalist, you're not only just looking at nuclear companies. And so right. What is it? When one guy I talked to as an investor, he said, well, are you betting on the horse? You betting on the jockey, right? So how do you think about when you're looking at a deal, somebody comes to you with a company, what is the thing that makes it, that pushes your intrigue button, that makes you write a check? Is it are there one things that more than another? Is a charismatic leader, is an amazing technology? What separates the deals that you write checks for versus those that you don't?
It certainly is the team. That's the largest risk factor, I believe, in the 70 deals I've done in my life. When the team couldn't handle it, the company didn't succeed. And by the way, a key element of team is fundraising. Mm-hmm. So you've got to sort of, and you don't sort of show up at your first presentation. Oh yeah, they've got it or they don't. You learn over time the pattern of people. And one of the key things there is clear, linear discussion of the problem, clear, linear discussion of the solution. When the executives running the business can explain the problem and explain their solution to you, you've got a better than even chance that they're going to pull it off. Because they can do that, they'll be able to raise money, they'll be able to attract people, and ultimately they'll be able to attract customers. And
so they can define what it is that they're doing, what they're looking at.
Clearly. One of my most successful deals is Cloudflare, Matthew Prince and Michelle Zeitlin up in San Francisco. He was masterful at explaining the problem. And
what is Cloudflare? I'm sorry, I don't know what that.
It's a network-based content distribution, but mostly cyber. So their promise to people with long tail, so not to Microsoft, Google, or Apple, but to everybody else, they could give you Microsoft, Google, Apple security for your little business. So when I took over Red Seal as the CEO, the first thing I did was subscribe to Cloudflare for my internet traffic so that I could know that it was, and I only paid, I don't know, $19 a month or something. When you're a small business, the last thing you have is resources to go after the cyber issues of the day, which are many and complex. So Cloudflare provides that for small businesses and now big businesses. And then they also accelerate, they make the internet faster and all kinds of stuff. So it's just taken the world by storm. It's very.
So you said that was successful, but it was because of the founder. It was the founder. I forgot. What was his name again?
Matthew Prince.
And so what made you write the check was his own ability to see and define the problem and see how to solve it.
Yeah, and the problem I knew was big.
Gotcha.
Providing high quality cybersecurity for small business.
And so
that was in 2009 or 2010. Yeah.
Gotcha. So that was a deal that you personally did, but then what did
Venrock did that.
Venrock did that. Okay. So then you now you have 10 or so investments in nuclear, but overall in your portfolio, you said there are 20 or more.
Well, I did Roku as an investment. I did Nest, which was acquired by Google. There's several deals. The COVID and the situation really made several of these companies crank off. One was called Luma Health, which was basically a scheduling service for physicians. So when suddenly people had to schedule and wait and all this sort of stuff, it just exploded. They got acquired by a PE group, and I made a nice return on that. So But look, I'm an early stage. I'm typically the first money in, and I've got plenty of little tiny craters out there too.
So then I asked Peter Zion, who was on the podcast recently. He wrote his book, "The End of the World Is Just the Beginning," and I've asked a lot of other people who've been on the podcast. So we're in a world where there's a lot of upheaval, there's a lot of uncertainty, and I know you invest in early stage companies, but what makes sense to you now? Zion was big into commodities. A lot of people are long the dollar and short Europe and short Asia, and Zion's very bearish on China. So if I know you're not giving investment advice, but what makes sense to you in today's world as an investment for a retail investor, someone who doesn't have your knowledge and your depth of knowledge in Silicon Valley? Is it U.S. equities? Is it dividend paying stocks? What?
Oh man, well, it depends on where you are in life and what you need.
Yeah, well, there you go. Okay.
I mean, for me, I'm looking to move some of my growth portfolio into fixed income related things. But look, I think it's a big question, Robert. I would say things that empower people to do their business are very interesting things. That includes taking care of my own medical situation. That includes taking care of my groceries. That includes taking care of my power needs at my home. That's one category. The other category is instrumentation. It seems to me, and I'm an engineer, so there's a big bias here, but when you can, and I didn't make this up, but when you can measure something, you can manage something.
Right.
And if I give you the app to manage something that saves you money, that's a big deal.
Right.
And it's not just you, it'll be, 100 million other people. So, Uber and Lyft, those are incredible inventions, just incredible inventions. So we don't have to own a car. Right. I know so many young people that don't own cars.
Right.
They don't even have a driver's license. So that's transformative. So so those kinds of things I think are what was it? Peter Finch used to say, invest in things that you use and know.
Peter Lynch from
Peter Lynch. Thank you. Not Peter Finch. Peter Lynch.
The
right?
Magellan Fund, right? Wasn't that Fidelity exactly. Magellan? Right. Yeah.
So if you're looking to do some of this stuff today, I think you need to invest in things you know and understand. Nuclear power is
regional bias toward the U.S. toward the
U.S. Toward the U.S. Yeah.
Right. Yeah. I'm bullish on the U.S. because
we're what 40% of the economy of the world. I mean, it's so long as we don't kill the capital machine that we have here, that is people taking risks. I mean, look, I work for the Rockefellers, who were some of the first early money, big family office money in the first quarter of the 20th century. And think of the stuff they invested in. They invested in, Lawrence Rockefeller invested in James McDonnell, jet engines. He helped Eddie Rickenbacker buy a division of General Motors to create Eastern Airlines. I mean, this is what some of these early people, and now venture capital is an asset class all on its own. It's full of all kinds of risk profiles and stuff. And there are a few folks like me and many, Venrock, NEA, Greylock, we all still take these giant tech risks because we know tech lowers the cost and raises the benefit for everybody. Look, last thing I'll say, when I got into venture in 1988, the Wall Street, the NASDAQ in those days mostly, represented about 5% of the total cap of the public markets. 5%. You know what it is today?
No.
The last number I saw, it was about 55%.
So all the market capitalization of all the equities in the United States, NASDAQ is half of it?
Well, no, tech is half of it.
Okay, tech is half. I got
So we're talking Apple, Google, Facebook. Think about it, these are trillion-dollar Tesla. These are trillion-dollar companies.
Sure.
I don't see many trillion-dollar pharmaceutical companies or oil companies or
steel companies or any of
but you know what I mean? Yeah. So tech is really, and that's because people value it. People buy the products from these companies, and that's the true north.
Sure.
So I think tech matters. It's not perfect, but it matters a lot. So
right. So last two questions, Ray, and I asked you before we started, what's your call to action? You don't have one. You don't have a website. You're not looking people to follow you on Twitter.
No.
So the questions I ask always at the end of these. So what are you reading these days? Do you have any books that are at the top of your list? If so, what are they?
Well, I got one. I just started. I just happen to have it right here. This was published by Gene Becker, who was George Bush's personal assistant. It's called The Man I Knew, about George Herbert Walker Bush. He was one of my heroes. His museum is at Texas A&M, by the way.
And why was he one of your? Tell me, why was he one of your heroes?
Because he was a very dignified, smart guy who cared about other people more than he cared about himself. I met him several times. I even met him once when I was in grad school at MIT, and kept up with. Anyway, it's just a style of living and a way of living that was sort of imbued on me, and I really identified with it. So I think this is like at the top of my list. The other book,
and it's called The Man I Knew by Jean Becker. Is that right? Yeah.
Yeah. Okay. Jean Becker. She was his aide, and it's full of amazing anecdotes and observations that she had about this guy. She was with him for a long time. What's the other book? Of course, there's my book. Oh, here's another one. I'll punch this. Blue Oasis No More.
Oh, right. Blue Oasis No More by your former, one of your teachers at A&M.
Right.
And his name is
Glenn Duckett, D-U-C-A-T.
Right.
This book can be read by anybody. This is, it's not technical, but it's about the issues we face. And basically he says, we're beyond the point of no return on keeping life as we know it. So what do we do about it? And it's very practical. It's a super practical book. Each chapter stands on its own, so you don't have to, read 500 pages to understand what's going on.
Right.
I just read this one a couple of weeks ago and sent him some comments and sent it out to a bunch of friends for their inputs. Anyway, he self-published this on Amazon.
So the Blue Oasis No More and The Man I Knew. It's interesting you bring that up about George H.W. Bush, because he was one of the last internationalists that we've had as a president, right? That had been ambassador to China, really had traveled the world and really knew international relations.
And he knows what's going on under the scenes, having been the head of the CIA.
Right.
The other book, and my wife just got it, and I'm gonna, when she finishes, I'll read it. It's called The World, by Richard Haas. He just published it, I guess, 6 months ago or whatever.
He's the Council of Foreign Relations.
Right. He's president. Yeah. But it's about how the world's put together.
Interesting.
The politics, the social, the climate, the economics, where things are made, how they ship around, all that sort of stuff.
So we've been talking more than an hour, so I need to draw it to a close. But Ray, I always ask the same question of everyone: what gives you hope?
What? I'm sorry.
What gives you hope?
Well, listen, I'm a venture capitalist. We're always optimists. But what gives me hope is that there are enough good people in the world, like a supermajority of good people in the world, who will help their neighbor, help solve problems, help cure disease, help invest in things. Politics has gotten very ugly we could talk about that on another podcast, but I think, generally speaking, even my most archest folks who subscribe and vote for those other candidates, many of both sides that I don't like, they're good people. They help people. They are, they're charity. Time and treasure are the two things we have at the end of the day. And I've been lucky to live a very productive life that way. My parents, I grew up, they always were the den mother or Boy Scout leader or band PTA president, whatever. You have to be involved. And when we stop being involved with each other, that's when I think we're in trouble. And right now we're still very involved.
Well, I think that's a good place to stop.
Okay, very good.
Well, Ray, my guest has been Ray Rothrock. He's a venture capitalist based in California, a longtime venture capitalist and investor in nuclear energy and other technologies. You can look him up. He's easy to find on the Google, but he's not selling anything, so there's no website or Twitter handle. Ray, thanks a million for being on the Power Hungry podcast.
Robert, thank you so much. I so appreciate you giving me this time.
Great fun. And all of you in podcast land, tune in for the next episode of the Power Hungry podcast. It might be as good as this one. Until then, see ya.